Hello, in this video we're going to learn how to do the basics of breadboarding. We're going to build parallel and series circuits on a breadboard. But before we start building circuits, let's talk a little bit about the breadboard. The breadboard allows you to put together some simple circuits and test your electronics easily before you build a printable circuit board. Some important features about the breadboard is that each of these rows right here are connected by a metal plate that's underneath this plastic top. And so A through E, these holes are all connected. These are all being joined by the metal plate underneath. And then F through J are all connected. But each column is not connected. So something plugged into A1 is not connected to something plugged into A2. But A1, B1, C1, D1, and E1 are all joined together. Now you'll notice there's this deep canyon right here in the middle between E and F. This is a separation between the rows. So notice on my resistor here that I have set up, even though it's in the same row, they are not connected because I took it across the canyon right here. This is going to be really important in setting up our circuits. So you just want to be really careful not to put a wire in straight across the same row because you're short-circuiting, because this is all connected is one big loop. So nothing's going to happen here. So if you want to make a connection, you would put it in one row and then in another row, and that's going to join this row to this row. Okay, so let's talk a little bit about series circuits. Let's set up a series circuit to connect my three resistors. These are each 1 kilo ohm resistors. And so what makes something a series circuit is that it really has only one path to travel. So if I were to plug in my positive right here, and you're going to need, in order to do this, you're going to need a breadboard. You're going to need some jumper wires, and you're going to need a 9-volt battery with the battery leads on the top. Now I'm going to hook in the positive next to my resistor here. So current is going to flow from the battery through the red wire across this resistor, and now I want to connect it to the middle resistor. So I'm going to take a jumper wire and I'm going to put it on the top here. And on the bottom here. And notice that my wire is in the same row as the top resistor, and the other end is in the same row as this middle resistor. So current's going to flow through the red wire, across this resistor, down the blue wire, which will take it over to this side. So now I need to connect this middle resistor with the bottom resistor. Let me get another color just so I can refer. And so now this is my series circuit where the current's going to flow here across this resistor, across the blue wire, across the middle resistor, down the green wire, and across the third resistor until finally here's my negative coming out. When I plug it into the same row as the end of this resistor, I'm completing my circuit. So this is an example of a series circuit because I have exactly one path for the current to travel. Now something important for you to realize about a series circuit, I'm going to unplug my battery here for just a second, and I'm going to use my multimeter, and I want to set it up to measure resistance. So down here I'm going to set it up. Each of these is 1 kilo ohm, so I'm going to set my multimeter to 2 kilo ohms, and I'm going to measure my resistance across this one resistor. And I get 0.9, so almost 1 kilo ohm. If I measure across this one, I get 0.9, which is almost 1 kilo ohm. And if I measure across this third one, I get 0.9, which is 1 kilo ohm. Now watch what happens if I measure across from the beginning of the first resistor to the last resistor. I'm measuring total resistance, and notice it's giving me a 1 on my multimeter, which means that I have too much, so I need to go a step higher. I have more than 2 kilo ohms. So if I measure again and I put these on, I have 3, which in series as our calculations taught us from the worksheet, when you are in a series circuit, your resistance is additive. So you add this resistance plus this resistance plus this resistance. So we should expect 3 kilo ohms of resistance there. Now, what does it look like if I take this same circuit and I wire it in parallel? All that parallel means is that you have choices. Whenever this current comes in here, if I put my battery back in to enter the circuit, and then I want to give it some choices. So maybe I will take another green, and I'm going to give it some options. So it can go this way and this way. So now what I've done is I've made a path for the current when it enters. It can either go to the resistor, or it can travel this green wire and go to this resistor. So now I've just made my series parallel, or my circuit parallel. I'm sorry, I said the wrong word. Next, let's give it some more choices. So here, if I put this, because see, if they're in the same row, they're all connected, then I can put this right here. So now when the current enters my circuit, I have a choice to go across this resistor and come down here and go across this resistor. I can go across this resistor and come straight down and come across this resistor. And so now I have choices. That's what makes this parallel. And then I'm going to put my negative leading out. So current can enter. We have choices on which direction it can go, and depending on what choice it makes, and then it comes out the black negative wire. This is a parallel circuit. Now I'm going to unplug the batteries for just a second to show you our relationship with our multimeter again. I'm going to put it back on 2 kilo ohms. Excuse me. And I'm going to measure each individual resistor again. And I get 0.3. And I get 0.3, and I get 0.3, 330, which if I measure across the total resistance, total resistance should be 1. There it was. I can get my things in the right spot. And then each resistor is a third of that. Because I am measuring, this is a parallel circuit, your resistance is divided. And so now I have less resistance. So the overall total resistance should be 1, and each one of these is a third of that, which is 330. So that's the little difference between parallel and series circuits. Now, for our activity today, we would like for you to take some diagrams that are on your worksheet, like this one, and we want you to mark it. Let's go this way here. Okay, and we would like you to use your breadboard to make this particular circuit. So the symbols that we have here is this symbol right here is for the battery, so that's where we're going to put our battery leads in and out. Then we need to have a 330 ohm resistor. So I'm going to start to try to set this up. I'm going to have my battery in, and then I'm going to need a 330 ohm resistor. So I'm going to put it next to the red, and I can either come down this way and move it in a different row, or I can come across this canyon and keep it in the same row. So there's my 330 ohm resistor for this part right here in the scheme. Then I'm going to have a switch. Notice on my switch there's 2 little prongs, and they're very, very tiny. And so I'm going to want one in a top row and one in a bottom row. And then how I connect the resistor to the switch, I'm going to move this over so we can see. I am going to put a jumper wire that connects the 2 rows. So I'm going to put a jumper wire here from the end of the resistor to another row, and then I'm going to plug in the first piece of the prong for the switch, and then the other piece is in the row below it. And this little symbol here is our symbol for a switch. Then it wants me to have an LED. So I'm going to take an LED, and something important that you need to know about LEDs is that they are a diode, which means their current only flows one way. If you'll notice on this LED, if I can hold it just right, the one side is rounded. This side over here has a rounded edge, and then you can touch this side right here. It's really flat. They've cut off this side to make it flat. The flat side is the side that current cannot enter. So current flows in through the rounded side and out the flat side. You can also tell by the length of the wires here. Maybe if I hold it over this white paper. The positive side, or where the current flows in, is longer than the leg that is negative, where it flows out. So you have to pay attention. In my circuit here, my current is coming in the red wire, across the resistor, down this jumper cable, through the switch. So I'm going to want the rounded side of my LED in the same row as the bottom of the switch, and then I'm going to put my negative side across. Okay? And then I am going to change it so that I have my, I'm going to complete the circuit by, now that I have my LED set up, I can put my negative wire in the same row. So this is what it looks like on paper on your assignment. This is what it looks like on the breadboard. And then they ask us to measure like a voltage with the switch open. So I'm going to measure voltage, and I have it hooked up to a 9-volt battery. And so I can take I've got my multimeter set on 20. Let's see if I can get all of this in the picture together. And I'm going to measure the voltage across my battery. So positive to negative, it is indeed 9-volt battery. If I can hold it still, it'll get still. There we go. So I have about 9.48 volts across the battery. Now the switch is open, and I can push it and close it, and you notice that not if I move these wires out of the way, our LED lights up whenever the switch is closed. So I want to measure the voltage whenever the switch is open. I'm going to measure the voltage across my resistor, and I get 0 because there's nothing flowing through it because the circuit is open. And I'm going to measure across my LED, and remember to put the red on the positive side, or the rounded edge, and the black on the negative side, which is the negative edge. And I still get 0 volts. Now my trusty assistant is going to join me and push my little button. We're working together today so that we can see it light up. Vanna, if you would push the button. Then I can measure my voltage across the resistor at about 7, and with the switch closed again, we're going to measure across the LED, and I get 2.2, and you'll remember my total voltage was about 9.4, so the voltage of the resistor plus the voltage of the diode should add to be the voltage of your battery. And so you're going to measure things like this. You're going to set up several different circuits today in your activity based on schematics, such as this one off of your worksheet. Some of them will be in series. Oh, I do want to point out this right over here. This V is not part of your circuit. It means that they want you to measure voltage. And if they have an R or an A in here, then that means that they want you to measure current. And if they have, let me get my little thing here. Oh, an M in here. If they have a little M instead of a V, they want you to measure resistance. And so that's how you'll know what you're measuring. That's all this is showing you. It's not actually part of the circuit. So now you're going to take readings and use what you've learned about breadboarding today and work a few of these on your worksheet. Oh, one more thing before we go. I get ahead of myself. I did want to show you something with my parallel circuit here. I've set up a parallel circuit, something to be careful of when you're working with these LEDs. They absolutely just go one way. So you'll notice here I already have a parallel circuit set up. It is parallel because I'm going to have my current enter here. It can go through the resistor. Once it gets through the resistor, it has a choice to follow the blue wire or the LED. So since it has a choice of what path to take, it's going to be set up in parallel. So my current is going to go in the same row as my resistor. And I really just have the resistor here so that I don't send too much power through these LEDs. So I have a resistor first and then my LED, and I have this set up in parallel. And then I'm going to have choices here, and I'm going to want to come out at the end of one of these. Oh, if I can get my wire in there. Get it straightened out and stick in there. Stick it right over here. Notice when I make a good connection, oh wow, only 2 of my LEDs are lighting up. I think there might be something wrong with this one. Maybe it's a faulty one, so we should just throw it away. No, 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 not so quick. We're not going to do that. First of all, remember I told you that they are definitely one way. So current only flows in one side and out the other. So when I start looking at analyzing my circuit, I have current, get my pen so I can push here or show you here. I have current coming in the red wire. It comes through the resistor, and when it turns to go through, it would go across the LED in this way. And I happen to have the flat side on the side that current is trying to enter, and the rounded side on the side where current is trying to exit. And that is absolutely wrong. Watch what happens when I turn my LED around. Now I have all 3 of them lit up. So it really does matter on these LEDs that whichever direction your current is entering, you have the rounded edge of the LED on that side. And depending on whether you set them up series or parallel will matter on whether you want all the flat sides on the same side or whether you want them to alternate. So you really do need to pay attention and analyze and follow that current through so that you know where the current's going to be entering, so you can put that rounded edge of the LED there. And I believe that is all that I need to show you for this part of the video. Happy breadboarding!